So I guess we're doing ODEs. So eigenvalues, eigenvectors, ODEs. I forget what order what part is this? 4? 5? Okay. Who thinks it's part 4? Who thinks it's part 5? Okay, part 5. Okay. You lose. All right. All right. So let's do. So I'm gonna recap what we did. So we solved an initial value problem. So in ordinary differential equations, we talked about converting high order differential equations, linear differential equations in one variable to a first order differential equation in many variables. So it turns it into this matrix thing. Okay. And then we talked about solving these and using eigenvalues to solve these. What we got, so what we had was, again, the objective, let me write down the objective. So eigenvalues, eigenvectors. And then we had solving ODEs. Okay, so, all right. So let me recall what we were doing. So we considered the initial value problem. Initial value problem, right? So we had this 2 by 2 thing. Y prime of t is equal to a y, right? Or let's just, I'll write y of t every time. Okay. And then we did y of 0 was equal to y10, y20, okay? Where A was a particular matrix, where A was this 2 by 2 thing, -2, -2, 1, 0. Okay, so so the solution. Okay, so then so we found eigenvalues and eigenvectors. Okay. So we found eigenvalues and eigenvectors for the matrix for A, and these were the following. -1 plus I, 1. Lambda 1 was -1 plus I. And then we had C2, which was -1 minus I, the conjugate of this, and lambda 2 was the conjugate here. Okay? So what we did was we expanded y in terms of the eigenvectors, right, to decouple the system. So we decoupled the system by expanding y in terms of the eigenvectors. Okay, and then so this gave a solution, allowed us to write down a general solution, Okay, and so the general solution looks like, looks like y of t, looks like C1, right? E to the minus t, e to the it, C1, right? So this little piece we got from, so the simple differential equation associated to this eigenvalue, right, plus some constant c2 e to the minus t e to the minus it c2, like this. Okay? So the next problem that we had was to solve for the constants c1 and c2 given the initial values. The initial condition. y0, y10, y20. All right? And so, so how did we do this? So we actually got this equation. So the equation that here, C1, C2, was equal to E inverse Y10, Y20, where E was the change of basis matrix for the eigenvectors, right? E was this thing, minus 1 plus I, minus 1 plus I. So I'm just going to put these eigenvectors here into the columns of the matrix, okay? So this one's 1, and then we have minus 1 minus I, 1. All right? Okay. So, and then we computed what the inverse of a 2 by 2 matrix was, right? The inverse of the 2 by 2, we reviewed what that was. Okay, so we're now all experts on inverses of 2 by 2 matrices, right? And E inverse is 1 over 2I, 1 minus 1, 1 plus I, 1 minus 1 plus I, like so. Okay? So, and this gave us a solution for C1 and C2. So that C1 was the following crazy formula. So 1 over 2I, y10 plus 1 plus I, y20. So I'm just kind of writing out this times this. Okay? Or sorry, not that E, but this times that y10, right? So I'm taking the y's and I'm multiplying. Okay? And C2 is 1 over 2I minus y10 plus minus 1 plus I, y20. Okay? So this gave us a solution to this problem. Okay? So we have these crazy coefficients here, and we have this thing which is explicit. So everything now is explicit. Okay? And we have a solution to this differential equation. Okay? So it looks like a crazy mess, right? Okay? And so my claim is that when you specialize this to certain values, right, at the end of class, that you get something very specific. Okay? So so this is what we had. And so maybe we can kind of store this information somewhere. Okay? So let me recall. Okay? So there's lots of complex numbers involved. But my claim now we claimed the following, that if you look at this system of differential equations, one like this, right, then we get something nice. Is equal to e to the minus t cosine t minus 3 sine t cosine t plus 2 sine t. Okay. So let's see if this works out. All right? That's what I want to work out today. Okay. So so let's figure out what these C's are. We'll plug them into the solution with these particular. So we're going to take our solution here, and we're going to do y10 is equal to. So in our solution. Okay. We take y10 is equal to 1 and y20 is equal to 1. And we're going to check that it's nice. Okay? So let's actually write out what this is. All right. Okay, so we have these expressions for C1 and C2. And maybe I can, let's copy some things over here for future reference. Okay, so for future reference, let's write down what y is. So y of t is equal to C1 e to the minus t e to the it C1 plus C2 e to the minus t e to the minus it C2. This thing here is this vector. This thing here is this vector. Okay, and then C1 was equal to, let me just copy it here. 1 plus I. And then make sure that it's a minus. This is a minus here. And then I have plus negative 1 plus I y20, like so. Okay? So we're going to keep this here for future reference. Okay? So let's start on the C1s and C2s. Okay, so the first thing I want to check here is I'm going to check that this is even a real solution. Okay, so note did I say? Okay, yeah. So this is our other solution. So the first thing to check wonder about. So is this a real solution? Right? So we have a real matrix. This matrix has real entries, right? It's a very particular 2 by 2 matrix. The initial values are real, right? So the solution should be real. Yet, right, it looks like the solution has a bunch of complex numbers in it, right? So that's something we should be able to verify quickly, right? Okay, so let's do that. Okay, so C1. Okay, so this is equal to 1 over 2i, and now I'm just going to plug in 1 for everywhere. So this is 1 plus 1 plus I 1. Okay, so this is equal to 1 over 2i, like so, and then we have 2 plus I. All right, so what's 1 over I? 1 over I is negative I over 2, 2 plus I. Okay, and I times negative I, that's 1. So this is 1/2, and then I'm going to get 1 minus 2I. Okay, C2, this is 1 over 2I. Right, and now I'm just going to plug in 1s again. Plus, minus 1 plus I, 1, like so. Okay, and now what do we get? So I'm going to do the same thing again. This is minus I over 2. because 1 over I is so really, this is the multiplicative inverse of I. Minus 1 is also the multiplicative inverse of I, okay? Because I times I is -1. If you throw another -1 in there, you get 1, okay? So now this is -1, -1 plus I, okay? And so this is equal to, so let's write it over here, minus I over 2 minus 2 plus I. Okay, so this is 1/2. And now we have 1 plus 2I. Okay? So these two things are complex conjugates of each other, which is convenient. Okay? So now let's put this into our solution. Okay? So we have these two constants, and they happen to be complex conjugates of each other. So we have kind of a new updated version of what C1 and C2 are. Okay? So let's put these in. Into our solution. Okay. Maybe I'll make some space here. Okay, so let's write down our solution. So y of t, this is C1. I'm just going to copy it down again. E to the minus t, e to the it, and then I'm going to write out what this one is here. Okay, so it's -1 plus I over 1, right? And then we have plus C2, e to the minus t, e to the minus it, okay? -1 minus I, 1, like so. All right? Okay. So now let's put in our C's. Our C's are, well, C1 was 1/2, and then I'm going to do 1 minus 2I, e to the minus t, e to the it, plus, I'm going to do 1/2, 1 plus 2I, e to the minus t, e to the minus it, and then I do -1 minus I over 1. Okay. Can anyone see why this is real? So you should be able to look at it. Oh, wait, I forgot something big. Oh, no. Okay, let me cram this in here. Plus, what is it, 1/2, 1 plus 2I? Okay. Can anyone see why this is real? So this is something maybe we should get better at. So what about this? So like, is there a symmetry between these two things? Yeah, they're complex conjugates, right? And so what happens when you add two complex conjugates? Yeah, it's like you get the cosine, yeah. So, but let's recall, I'll do it over here, that z plus z bar, right? This is, well, 2 times the real part of z. So this is a real number, okay? So this is, so here's like a little proof, right? You know, x plus iy plus x minus iy, right? And this is equal to, well, 2 times x. Right? So here, so note that this thing here is 1/2, 1 minus 2I, e to the minus t, e to the it, minus 1 plus I over 1. And then all the signs are flipped, plus 1/2. And we have this. Let me just write, and we're going to write the exact same thing down. So t is a real number here. Right? And we have that. So this is the complex conjugate of that. So this thing, well, we could bring out the 1/2, but this is 2 times the real part of this whole thing. Okay, and so here I'm talking about the real part of a matrix, so this vector. So to take the real part of a vector, I just mean take the real part of each of the vectors. Does that make sense? Does this notation make sense to you guys? It's some nods, some like circle heads. So let me, maybe I can explain this a little bit further. So what we're going to do is we're just going to put everything into, so let's recall some properties. So maybe this is helpful to do. Okay, so there's some other properties of complex conjugation that I mentioned, but it seemed like I was going quickly and just maybe saying things that I wasn't going to use. But let's recall here. Where should I do this? I'll do this over here too, next to this other part. So we recall. So this is a very important property, that if Z1 in W, or Z and W are complex numbers, then Z plus W bar is Z bar plus W bar, and Z times W bar is equal to Z bar times W bar. Okay, so it respects the operations of multiplication and addition. Right? If anyone's taken abstract algebra, it's a field homomorphism, field isomorphism. Okay? So we're using this property, right? In particular, since we're seeing that all of these things are conjugate, right? So you can really see that this thing, like individually, right? This thing is the conjugate of this, right? This term here, or let's do it like up here. This one's the conjugate of this one's the conjugate of this, and this one's the conjugate of this, right up here, right? And it turns out that if you have a bunch of conjugates multiplied times each other, you can take the bar up, right? And so really, you can do the complex conjugate of the whole thing. It doesn't matter if you take the complex conjugate first, and then you multiply them out, or you multiply them out, and then you take the complex conjugate. Okay? So that's a useful property that we're using right now. All right. Okay, so it remains to compute what this thing is. Okay, so we need to compute. So does this make sense as to why this is real now? Okay, everyone's giving some nods. Okay. Okay. All right. All right. So let's compute what this is. All right. And so really we can. Sorry, this is too real. We were supposed to have a half here. Sorry. Okay. And really, let me just clean this up a little bit. Okay. So this is equal to e to the minus t. I can bring out e to the minus t times the real part. So these halves will cancel. Okay. So if you take the real part of something, or if you take a complex number and multiply the whole thing by 2, the real part of it is also going to be multiplied by 2, right? So you can pull out constants here. This is a real number. This is a real number, so you can pull it out. Okay, and these two parts cancel. All right, and so this part here is the real part of 1 minus 2i, e to the it, and then we have minus 1 plus I, 1. Okay, so let's compute out what this is. Okay, so the halves went away, and I pulled out the e to the t. Okay, so 1 minus 2i, so this is like scratch work, I guess. So let's compute what this thing is, e to the it. And we're really only cared about the real part of this thing. So this is cosine t plus I sine t. Okay, so what is this thing? So this is equal to cosine t, right? And now we have a minus, well, let me just write it out, okay? So we're going to have plus. So there's a faster, in practice when you're doing this, we don't really care about the imaginary part, okay? So you could actually drop that out, right? It'll be, but I'll just write it out just for completeness. Okay, sine t, so I did this thing. Then we have minus 2i cosine t, so this is another term we don't care about. And then we have a minus 2i times I sine t. Okay, so this is going to be cosine t And we'll break it up into real and imaginary parts. So plus 2 sine t, okay, minus or plus I times sine t minus 2, I guess minus 2 cosine t. Okay, so we have that. I guess we do care about this imaginary part because we're going to have to multiply it times this thing later, this part here. Okay, so this tells us that, so 1 over 2i e to the it minus 1 plus I1. So this is just like, I'm peeling off just a part of this, and I'm going to put it back in later. Okay, so this is equal to, well, we have this stuff, right? So we're going to have this thing, minus 1 plus I, times this whole thing. Cosine t plus 2 sine t plus, so that thing, plus I, sine t, and I'm going to get rid of this, plus I sine t minus 2 cosine t. And this is like another area where you can make a lot of mistakes. Okay, and then we just have this part here. So cosine t plus 2 sine t plus I sine t minus 2 cosine t, like so. All right? So I think this is the bottom. So you can notice that the real part of this is already what we had, right? So you can see that this part here was the term that I wrote down at the beginning, right? Because we're going to be taking the real part of this thing. Okay, so we need to mix this up. So let's compute what the top is and verify that it's what I said. Okay? So let's expand out. All right. Okay, so we have minus 1 plus I. So this is equal to, now I'm going to do some, this thing times, now I'm just going to do a shorthand, okay? So I'm sick of writing cosine and sine all the time, so I'm just going to do this. C is cosine t and S is sine t. Okay, so I don't have to like write cosine and sine every time, all right? So here we have C plus 2S plus I, S minus 2C, right? That's the only thing that I needed to compute. And we really only cared about the real part, but let's just do it anyway. So this is minus 1 times C plus 2S. Then we have, plus a minus 1 times I, S minus 2C. Okay, and now we have I times C plus 2S, and then we have plus I, well, we have I squared, right, S minus 2C. Okay, and so this part will be here, so we'll have this thing. So we have, so am I missing a sign somewhere? I'm just concerned that we have minus signs. Okay, well, let's see what happens. Okay, so we have minus C minus 2S, and then we have this part. So we have minus S plus 2C, because I squared is minus 1, plus I times, and then we have this one, minus S minus, or plus 2C. Okay, so we had this minus is plus. Okay, and then we have this term here, plus C plus 2S. Okay. Okay, and let me just see what these things are, and pray that it's the same thing I got before. Let's see, 3S, and then we have plus C plus I times minus, so we have minus, we have S plus 3C. Okay? All right, so this tells us what this term is. Okay, so this gives us, so I'm going to, so now I can write out what that thing is. Okay, so this shows, this proves the following, that, this thing, y of t, and then I'm just going to copy this down, e to the minus t, the real part of 1 minus 2i, e to the it minus 1 plus I 1 here. Okay, so this thing is e to the minus t. And now I'm going to write out what we computed, right? Our first computation showed that, so what do we have? So our first computation gave us this. And so we're just only concerned with the real part of this thing, right? So this is going to be cosine of t plus 2 sine t. Oh, let's see, that's the bottom part, sorry. Yeah, we have cosine t plus 2 sine t. Okay, and then the top part was this thing. So the top part was this expand. So like what we did is we have to do this thing. So we had this term here, which we computed out. And now we have to multiply it times this one. Right? That's what this is. Right? And we just get this term here, which is this, which is cosine minus 3 sine t. Okay? And so this is how we got that. Right? So this is our answer. Right? So this is, yeah. So it's a slog, right? It's a little bit of a, a slog through this thing. Okay. So, so one thing you can do, right, is to go check, like after you do an example, right? Because all these things are very error prone, right? The more that you manipulate an equation, the more likely it is that you're going to introduce an error in your computation, okay? So, it's just the thing about writing, right? The more you write, the more chances are you're going to miss a sign, okay? So kind of like the less you touch something, the more stable the thing is going to be. So the fact that you're doing these computations by hand, right, means that it's likely to introduce errors, at least for me, right? Some people are way better, like the kids at the math bee who beat us, right? Right? I introduce errors. So one thing you can do is you can go and check the solution again, okay? So you can go take this and make sure it's actually a solution of the differential equation and it satisfies the initial conditions. And by the uniqueness, it has to be the solution, okay? So okay, so then on Monday, I'm gonna start something a little bit different, okay?